If at some point in this video the implications of what I am showing and telling you sink into your head, do not bury your head in the sand and whimper as we bear in mind that the geochemical composition and pretty coloring of the planets in our solar system, beginning with the gas giant outer planets and their ring structures, are more or less mere images of the pretty coloring and chemical composition of these photodiodes and multi and hyperspectral camera filters and digital imaging chips and lenses and so forth of all types and applications. The comparisons in color extend to the colorful ring structures of the gas giant planets compared to these multispectral filters for camera lenses, whereby the respective color bands of gas and dust and rock and other matter swirling and orbiting around the gas giants are nearly identical to the color bands in these multispectral color filters, as well as in certain types of ultra-high resolution multi and hyperspectral digital camera and imaging chips, with each color band being sensitive to its own unique color spectra. These chips include CMOS and CCD and DSLR chips that are used in everything from standard photography to broadband photometry to astrophotography, microscopy, and so forth. The acronyms for these chips respectively stand for Charged Coupled Device, Complementary Metal Oxide Semiconductor, and Digital Lens Reflex, all of which are semiconductors of electricity, just like the planets and moons in our solar system, with lots of silicon in their chemical makeup, which is a semiconductor. I am not going to elaborate on these chips, except to say that they convert photons to electrons and analog signals to digital signals, and they serve as a substitute for old-fashioned film and camera and imaging equipment, including telescopes and microscopes and spectroscopes and so forth. And they produce higher resolution images than traditional camera film, plus these images can be copied and uploaded and downloaded much easier than standard photographs and motion picture film and so forth. This means that digital imaging chips are being fused with cameras and other optical equipment, and when we focus on the pretty colors of the gas giant planets of Saturn, Jupiter, Neptune, and Uranus, we can see with our own eyes that they are colored like digital imaging chips as well as lenses. And we must also remember once again that the geochemical composition of the planets and ours and other moons in the solar system are also made of the same chemical composition of digital imaging chips and lenses and other optical equipment, insofar that they all contain lots of silicon and metals, including their respective oxides, including glass, which is essentially sand, and sand is silica and one of the most abundant elements in our solar system. And silica is used in the manufacture of digital, electronic, and optical equipment of all kinds. And as we continue comparing the pretty colors of the planets to the pretty colors of these lenses and digital sensor chips, let us bear in mind that the colors of lenses and digital imaging sensor chips have everything to do with their applications. With regard to the chemical similarities between digital imaging chips and the planets, it is significant that the latest lines of CMOS sensor imaging chips are being embedded with hydrogen and helium in their production processes, and hydrogen and helium are abundant in the planets and the moons in our solar system. What is especially significant here is that scientists and doctors have recently invented what is called a lab-on-chip biological sensor chip that in turn has been merged with a CMOS digital imaging chip, including what are called microfluidic biochips, plus other types of chips. as you bear in mind that over 70% of the surface of the Earth is covered in water. Microfluidic lab-on-chip devices use the forces of light and or magnetism as excitation and analytics and manipulation agents, and are used by doctors and scientists to study and manipulate cells and DNA and other matter at the molecular level. What is especially significant here is that microfluidic biochips are also finding themselves being used in microscopes in a dynamic that is a mirror image of our solar system, with this example of a microfluidic chip microscope being the only example I could find on the internet, with these other examples being some random examples that also abstractly mirror the dynamics of our solar system relative to the position of the Earth in our solar system. With the planets and our moon always moving around and passing by the Earth, as if some kind of lens and sensor and mirror array in the gigantic shape-shifting optical and fluorescent microscope array, or something to that effect, that we call our solar system, with all the planets and our moon in just the right place, so it seems, in their relation to the Earth. I think solar systems like our own are in part some kind of biological imaging system in which planets that evolve life are set up to automatically become the targets of this imaging and microscope and so forth system we call solar systems. I think the cores and layers of planets like the Earth play significant roles as some kind of opaque magnetic lens and sensor structures, as do the cores of the moons like ours, with the sun playing its roles as source of light in relation to its comparison as a source of light for these optically based sensor chips and related devices whose structure and dynamics appear to mirror the structure and dynamics of the Earth, the sun, and the moon relative to each other and relative to ourselves. We are the targets of the biological imaging and microscopy system we call the solar system. The following examples are just some random examples of magnetic sensor equipment, including equipment for the manipulation of magnetic nanoparticles. The Earth is some kind of laboratory on a chip. And when we bring in the sun, and bearing in mind that I recently noticed that most of the surface of the Earth is made of water, the Earth is some kind of optofluidic chip, just like these examples here. And these examples also have in a built-in CMOS chip. The core of the Earth is some kind of CMOS chip or CCD chip. Here are some more examples of the structure of CMOS chips and CCD chips, as well as lenses compared to the structure of the Earth and the other planets, some of them anyways. We can see with our own eyes how the layers of the planets, the sequence of the layers, and I would bet that the geochemical composition of the layers are also identical to the layers of these technologies that we are looking at. The core of the Earth is magnetic. It produces an electromagnetic field. Same with the cores of the other planets, or at least they used to, some of them, but they are electromagnetized. And I think that hard radiation from the sun is probably passing through the crust of the Earth and passing through us as well, and probably picking up information. But here are some more comparisons of some microscope apparatuses that specifically use CCD, CMOS, and DSLR chips. The electromagnetic dynamics among and between the sun, the Earth, and the moon are mirror images of the electromagnetic dynamics of these microscope apparatuses. I am going to conclude this video by saying that the Earth, in relation to the Sun and the Moon, is some kind of biosensor device. And I think that this relationship is also some kind of computer device. The Sun is some kind of computer write head. The Sun writes DNA, insofar DNA mutates in the UV rays. DNA is also structurally identical to computer code, more or less, considering that the base pairs in DNA are the equivalent of binary code. And if you like this video, give it a thumbs up and subscribe, and thank you for subscribing. And I have other videos out there that go into a lot more detail than this video.